Hello, my name is Staff Sergeant Mascroft, and I'm an instructor for the Digital Wideband Repair course at the Marine Corps Communications Electronics School in 29 Palms, California. Today I'm going to be covering the proper procedures for aligning the 5A4 IF test panel, which is located in the AN TRC-170 radio system. The information found in today's video can be located in TM 08658 Alpha, TAC 14/1, Volume 1, Chapter 6, beginning on page 6, TAC 737. The equipment needed for today's procedure include a signal generator, a power meter, a multimeter, a variable attenuator capable of 0 to 70 dB of attenuation, a 50 ohm dummy load, 2 RF cables, 2 adapter kits, your remote antenna alignment meter, W100 cable, and a special adapter, the instructions for which can be found in the previously mentioned portion of the TM. The procedure I'm about to cover is only a portion of that listed in the TM. The TM goes into much greater detail, however we here at the Digital Wideband Repair course have deemed it unnecessary for what we normally encounter. The first thing we're going to do is check the components on the IF test panel CCA. In order to do that, you need to release the 4 captive screws on the front of the IF test panel. Once that's complete, you can then open up the drawer and you'll see the IF test panel CCA located towards the front and about this area. Before you open up the drawer, go ahead and make sure that your 2 attenuators are set to 0 and your 4 IF loopback switches are all in the normal position. Once you locate the card, you'll notice several components. First thing you want to do is make sure power is turned off to the van. After that, you're going to find the 3 inductors, L1, L2, and L3. When you measure across these, they should indicate a short. After that, you're going to find R1. Measuring it, you should get about 1200 ohms. The last things you'll check are R2, 3, 4, and 5. All 4 of those resistors should read about 560 ohms. The next portion of the alignment we'll be covering is called the through signal test. In order to set up the IF test panel correctly for this alignment, you'll need to disconnect J6, 7, 8, 9, 11, 16, and 17 from the back of the 5A4. You will leave the 2 power connectors connected and also the ground connected. On the front, you're going to make sure the IF loopback switches are in the normal position and the attenuators are set to 0. On your antenna monitor, you need to set the meter selector switch to off and RSL integration to short. You will also at this point need to connect the RAM using the W100 cable to the exterior of the shelter. The first step in the through signal test is to energize your radio. After you complete that, you want to set up your signal generator to output 69.12 MHz at 0 dBm and connect it to J16. Then you want to set up your power meter connected to J9. This will check the main signal flow for channel 1. On your power meter, you're looking for a reading of negative 3.5 dBm plus or minus 1 dBm. Our power meter is reading negative 3.9 dBm and was within the tolerance range. If the reading on your power meter is outside of the tolerance range, then you will need to troubleshoot that channel. After you complete the process for channel 1, you will then repeat the process for channels 2, 3, and 4 using the appropriate inputs and outputs. The last part of the through signal test is to check the IF loopback signal flow for all 4 channels. In order to do this, you need to set up your signal generator to output 69.12 MHz at 10 dBm. You're then going to connect it to J11. After you do that, you need to connect your 50 ohm dummy load to J16, and you're going to leave your power meter connected to J9. This is going to test the loopback signal flow for channel 1. In order to do that, you need to make sure your IF loopback switch for channel 1 is turned on into the loopback position. After you do that and your signal generator is turned on, you should see a signal level of approximately negative 22 dBm plus or minus 1 dBm. Our power meter reads approximately negative 24 dBm, which is outside of the tolerance range. In order to correct this, you need to find the attenuator that deals with channel 1, which in this case is AT7, and properly adjust it. In order to do that, you need to grab a wrench and loosen up the set screw and then adjust it for the proper output for that channel. Once you've adjusted it for a negative 22 dB output for that channel, you need to make sure you hold your screwdriver steady and then tighten up the set screw nut so that channel stays at negative 22. Once you've completed that, you need to then complete the same procedure for the other 3 channels using the appropriate loopback switches on the front panel and the appropriate attenuators. The last part of the alignment procedure we'll be covering today is a log amplifier alignment. First thing you need to do in order to do this alignment is power down your radio. After you power down your radio, you need to disconnect the output from your log amplifier and connect the special adapter as previously mentioned. After you connect that special adapter, you need to connect your dummy load to J9 and then set your RAM to RSL13, antenna number 1, and set the bandwidth to constant wave. After you complete this, it is then safe to turn your radio back on. The next step is to set up your test equipment. First, you're going to connect your variable attenuator to your signal generator. Then set your signal generator up for a 69.12 MHz output at negative 6.5 dBm. After you set your signal generator up, you need to connect it to J16. After connecting your signal generator, you need to check the output of the A2 log amplifier across the resistor of your special adapter. You should get a reading of approximately 2.03 volts DC. After you get that reading, you then need to increase your variable attenuator in 10 dB steps and check for the voltages listed in the technical manual. If the readings you get using your multimeter are incorrect, then you will need to adjust AT12 in the same manner we previously adjusted AT7. After adjusting AT12 if necessary, you then need to switch your RAM bandwidth switch to the data position. After switching it to the data position, you need to check your multimeter for an output of the log amplifier of 1.35 volts DC. If that voltage isn't correct, then you need to adjust AT13 in the same manner we adjust AT12. After adjusting AT13 if necessary, you have now completed the 5A4 IF test panel alignment procedures.